Hi everyone, welcome to the May's Bradford Cloud User Group's live user event. Today we have three speakers. I'll give a quick breakdown of what you can expect. Then I'll hand it over to the speakers to do their own introduction on their sessions. Our first speaker is Maria-Anastasia, and she will be speaking about Azure IoT. The session is about 20-25 minutes, and it'll be a quick QA. If you've got any questions whilst Maria is speaking, just please put it in the chat. We'll ask Maria at the end. Our second session is Diliana. She'll be speaking about Microsoft 365 Dynamics and especially about Context IQ and the new aspects of collaboration. And again, followed by a quick QA. And our final speaker of the evening is Sophie Dimolo. I hope I got all the names right. Apologies if I haven't. Followed up by a quick QA session. And Sophie will be speaking about Microsoft 365 Business Premium and security features. Thank you for joining. Please subscribe to our YouTube channel. All the videos will be edited and added to the YouTube channel at the end once they don't email you all out. Again, thank you. I'll hand it over to Maria-Anastasia.
Thank you. Give me one moment to share my screen. I think that you could see my screen now.
Yeah, we can see you.
So, good evening. I hope you all are well and healthy. I'm so glad to be here, and I want to thank the hosts for having me here today. I am Maria-Anastasia, and I am a Microsoft Azure MVP. Moreover, I am studying computer engineering and informatics at the University of Patras here in Greece, and I work as a software engineer at the Team Candy of InfoQuest Technologies. I am also a Gold Microsoft Learn student ambassador and robotics teacher. Finally, I love to give presentations about Azure IoT, and I am a co-host of the IoT Live Twitch livestream. So I think that now we can take a look at what we're going to deal with today. This is our journey for today. So we will learn what the IoT is. Then we'll understand what Azure IoT is and how it works. After that, we're going to identify ways you can use the Azure IoT. And finally, we will examine the Microsoft vision for Azure IoT. So let's get started. First of all, Internet of Things is the communication network of many devices, as well as any object that incorporate that incorporates electronic means, software, sensors, and network connectivity to allow data connection and exchange. The sensors are typically embedded in the monitoring devices. These devices, known as IoT devices, have some processing power to control communications. The stream of data they generate is known as telemetry. The most used telemetry values, for example, are temperature, humidity, location, pressure, etc. Simply, IoT is the connection of all electronic devices to each other as a local area network or with the ability to connect to the internet. The term things now is not strictly associated with certain products. It refers to a wide variety of devices. The main feature of all of them is the connection between each other in order for the user to be able to control them from a computer or a mobile device. When we talk about IoT, we refer both to machine-to-machine communication and to machine-to-machine, of course, and to human-to-machine communication. Why is IoT so useful? First of all, IoT helps us in our daily life, and on the other hand, it helps us in tasks that are very difficult to take place without it. Moreover, once data is collected, it becomes possible to analyze it, to gain meaningful, actionable insights. These insights can help increase efficiency, reduce waste, or lower costs. Alternatively, might make smart spaces more secure because it will be more possible for IT employees to understand the data and detect security gaps. Why someone to deal with IoT? Except that dealing with IoT and with all of these sensor microcontrollers and all of these smart things is so fun, there is one more reason. As you can see, the total installed base of IoT connected devices worldwide is projected to amount to 30.9 billion units by 2025, a sharp jump from the 19 billion units that are connected right now. So, how to start dealing with IoT? First, you have to understand how IoT systems work. First, sensors like these here detect a physical property and send it to microcontrollers like this one, like this one. Then microcontrollers send this data to the gateway. Here we have a Raspberry Pi, for example, for our gateway. Finally, this gateway sends the data to Azure IoT. In the cloud, a resource known as IoT Hub collects the data and processes it. The hub might also communicate back to the devices, perhaps changing settings or parameters. Thus, we can inform about this data from our mobiles and from our laptops, for example. And here we have the must-haves you need to start dealing with IoT. First, you need a microcontroller. Microcontroller is a small computer on a single metal oxide semiconductor. That was very difficult for me, but I'm not native speaker. Hello. That contains CPUs and programmable input-output peripherals. Or a PCB, but nowadays we use for our IoT systems PCBs, printed circuit boards like Arduino, to processing all the information by sensors. In order to choose the right PCB for you, for your project, you have to think about how much space it should be take, how many peripherals it should have, and other questions like this. Of course, we also need sensors for detecting or measuring a physical property. Then we need breadboard and cables to connect the elements with each other. Those two are so important, but we often forget to put them on our shopping list. Breadboard is so important for the construction of temporary circuits and do not require any yielding. And this is the reason it's very important for you to have it if you want to deal with IoT. Next, of course, we need Ethernet connection to send the information to the internet. On PCBs that do not have a built-in Wi-Fi chip, as Arduino Uno, we need to put an extra microcontroller for Wi-Fi connectivity. We also need a gateway as Raspberry Pi, which receives the data from all the boards and uploads it to the server. The Raspberry Pi is a low-cost credit card size computer that plugs into a computer monitor or a TV, for example, and uses keyboard and mouse. It's actually a a PC. It is a capable little device that enables people to explore computing and to learn how to program in language like Scratch, Python, and yeah, like Python. Uh, it's capable of doing anything you'd expect a desktop computer to do. And of course, Raspberry Pi has the ability to interact with the outside world and has been used in a wide array of digital maker projects. And I love Raspberry Pi because it has a very good community, and this is very, very helpful. Finally, we need a server that accepts all our data. For security reasons, and not only for security reasons, but I use Microsoft Azure. And next, if you haven't all of these and you don't want to buy them, you can find online some simulators. My favorite simulators are the Raspberry Pi simulator. You can find here the Arduino simulator on Tinkercad, and then the FreeSync that contains many chips. In its case, you need basic knowledge of programming and electronics, like how breadboard works, how electronics works, etc. And last but not least, you need patience. And we are here. Next, I want to talk a little about Azure. First of all, as you all of us may know, Microsoft Azure is a cloud platform that has more than 200 products and cloud services. Microsoft has entered the IoT sector many years ago with a strong cloud-based offering, using pre-configured modules which enable a rapid deployment of an IoT solution. The service includes device specific SDKs for Visual Studio, support for Linux and Windows-based devices, and a cloud-based service which can quickly and reliably scale from a few sensors to millions of connected devices, of course, and of course with the secure of Microsoft. Why I use Azure IoT? Azure, yeah, for IoT. Azure IoT can help the organizations across all industries to solve a common set of business challenges to fuel innovation and digital transformation. Such challenges are complexity, cost, and security. Also, Azure IoT has excellent support, such as the Microsoft employees, as the huge community it has, and I think that you already know about this community. What does an Azure IoT architecture look like? The diagram illustrates a recommended IoT solution architecture. An IoT application consists of the following subsystems. First of all, things. Physical things with embedded sensors that are connected to the internet. Second, we have insights, the results from processing and analyzing the data. And last one, actions, the automated or manual response to the insights. Moreover, devices that can securely register with the cloud and send telemetry data. Alternatively, multiple devices might communicate locally with an edge gateway device. Next, we have a cloud gateway service or hub to securely read the incoming data and provide some device management capabilities. Next, we have streaming processors that consume the telemetry data, integrate with business process, and place the data in the storage. And last but not least, user interface to visualize data and enable easy device management. Now let's go to see some fields that Azure IoT helps and IoT in generally. Many industries can benefit by innovating with IoT. For example, we have manufacturing, transportation and logistics, energy and natural resources, agriculture, retail, government, healthcare, financial services, smart buildings and smart cities. But IoT is even on us. And finally, we are going to see which are the Azure IoT services. We have all of these services for IoT, but the first two services are the main Azure IoT services. There are more services like this here, and we can take a look together right now. Let's begin with Azure IoT Hub. Azure IoT Hub provides secure and reliable communication between our IoT application and the devices it manages. That's Azure IoT Hub provides a cloud host solution back and to connect virtually any device. Through the Azure IoT Hub, you can see various information to monitor your system and make your own custom solutions for how you want to for how you want this look from scratch. The main characteristics about Azure IoT Hub is that provides us with an extremely safe and reliable communication between the application and the devices it manages. Allows two-way communication, and as you can see in the picture here, is a platform as a service solution. Next, integrates with many Azure services that is extremely important, and has many programmable SDKs for popular languages like C, C#, Java, Python, Node.js, and finally supports multiple protocols like HTTPS, MQTT, AMQP. That's for Azure IoT Hub. Now we have the other main solution that is the IoT Central. IoT Central is similar to Azure IoT Hub, with the difference that IoT Central is not a custom solution. This solution offers communication with your devices too, but has specific templates. It's easily built on the Azure IoT Hub. The main characteristics are that provides us with an extremely safe and reliable communication between of the application and the devices too. Allows two-way communication like Azure IoT Hub, but is a software as a service solution. Provides templates, specific templates, as I told you before, and for this reason, it doesn't require deep technical knowledge. As we know, when it comes to data transfer and storage, we need to take the necessary measures to protect them. I think that you can understand that, especially in the Internet of Things, it's very important to protect our data and our system, because violating them can be very, very critical. That is why it's necessary to use a cloud system that is very reliable. Microsoft Azure Sphere is a solution for creating devices with high security. Azure Sphere is a secure end-to-end IoT solution which contains certified chips, and Azure Sphere OS based on Linux, and of course Azure Security Service Trust device-to-cloud communication. Azure Sphere certified chips include built-in Microsoft security technology to provide connectivity. Azure Sphere OS adds layers of protection and ongoing security updates to create a trustworthy platform. Azure Sphere Security Service brokers trust for device-to-cloud communication, detects threats, and renews IoT device security. And Microsoft security experts monitor emerging threats, design updates. Azure Sphere can be combined with Azure IoT Central, and of course, it can combine with Azure IoT Hub. I think I have 10 more minutes. Yeah, or yeah, okay, thank you. Now we have Azure Device Provisioning Service. This service is an auxiliary service for the IoT Hub, in which no human interaction is required, allowing millions of devices to connect in a safety way, of course. Azure IoT Ads is a combination of cloud service and runtime running on the device. And it's based on Azure IoT Hub too. This service has three components: modules, runtime, and cloud interface. And it's intended for those who want to analyze most of the device data locally instead of the cloud, either due to network issues or other problems. IoT Ads allows everyone to first, because it can run some functions on the device spends less time communicated with the cloud. Second, it provides cloud interface and runtime module, which allows us to manage our devices through the IoT Hub. And third, it allows the use of Docker compatible containers. And next, allows access to certified hardware, Linux or Windows devices that support container engines. Next, allows us to develop models that have been built and trained in the cloud and runs them on devices. And finally, uses the model to process data locally and responds quickly to the event. Azure IoT Ads use languages such as C, C#, Java, Python, and Node.js as well. And IoT Edge devices record large amount of data, but you usually only need a small portion of this data for further analysis. Due to this, IoT Edge reduce costs by allowing only the data portion needed to be shipped. Moreover, Often IoT devices need to work offline with the cloud. Offline with the cloud, and IoT Ads automatically syncs the latest device status as soon as it reconnects. IoT Ads provides security in a number of ways, such as in partnership with the IoT Hub, we can ensure that only the right devices can communicate with each other and that they have the right software installed. And IoT Ads can offer added security by integrating with Azure Security Center. Ads can protect our personal data, of course. This data can be cleared before being sent to the cloud, thus providing better protection of everyone's privacy. Finally, acts as a gateway and thus provide connectivity and analytics to IoT devices that would not otherwise have these capabilities. Next, I forgot to show you these slides, but I told you about that. And here we have IoT data analysis. We have Azure Time Series Insights that enables the display of anomalies in data, which can be difficult to detect visually. Thus, it automates the problem-solving process. We have Azure Maps. It enables the display of vehicle locations on the map and the calculation of the optimal route with many parameters and preferences. Azure Maps includes a number of features for managing geopolitical data. For IoT applications, useful features include traffic, routing, weather, and search. And finally, Azure Digital Twins. It's a very, very useful solution that enables the creation of digital models. Digital twins can be used to create solutions that manage system operations more efficiently. These environments could be buildings, factories, farms, energy networks, even entire cities. And last but not least, we're here. We have IoT Hub SDKs. We have Azure IoT Device SDKs, Azure IoT Service SDKs, Provisioning Device SDKs, and Provisioning Service SDKs. For advanced developer support, it used .NET, C, Java, Node.js, Python, and iOS. And I think that we can. I can show you this summary table I have made to help you remember these services if you want to have a clearly image of all IoT services. And one more summary table to help you remember the differences between each solution. There are some resources here. Of course, I have here our Microsoft Learn. I am a Microsoft Learn Student Ambassador, so I couldn't mention that. Next, we have GitHub. That is a great tool for developers, of course. Next, this is Sparkfun, Instructables, and Adafruit here. And that are great websites for IoT and electronics projects. And here we have my blog, and it's about the IoT. I think that that's all, folks, for today by me. I want to thank you very much for hearing me. And if you want to contact me, you will find me on LinkedIn, on Twitter, and on my blog. I am very active on these social media. Um, so if you have any questions, you can ask me.
Thank you, Maria. Great session.
Thank you.
There's a question in the chat about any recommendations for IoT kit.
For practice.
Yeah. I haven't a specific kit, but I think that on eBay, for example, or on some electronic local electronics local shop, you can find kits, but you can find all these must-haves that I showed you before, and make your own kit. When I first started dealing with IoT, I bought one kit with Arduino cables and breadboard, and then I bought a kit with many sensors.
No, thank you. There's no more questions.
Talking of developer kits, I bought this IoT dev kit. I think I paid about £20 for it. It wasn't brand new, but I know there was a mention, I think from Andrew, that there's also a web version as well that you can use. But I've got one of these. I'm not sure. I think Pete Code recommended it. Let's see if I can show you it. I've not used it yet. But, Pete Code's actually recommended this. Pete Gallagher. I did drop his. Oh, look at that. Yeah, trying to show some. Oh, stuck now. It's this
Whilst
here.
you're doing that,
Here we go. I don't know if you can see that. Oh, it's not zooming in, is it? There we go. Can you see it?
it's out focusing them.
Sorry, wait. If I just.
There
we go.
Yeah.
So yeah, I picked this up. I've never used it, but I need to.
I was going to say there was a question about test kit, but on one of Maria's slides, you were showing the simulators that you can use, Maria's, if you don't have the kit. So that might be a good way to start as well, because I know some of the kit isn't available at the moment. Like you can't get a Raspberry Pi. They're very limited at this moment in time because of stock.
Yeah, Simon just mentioned that in the chat.
Yep, they're all sold out.
Simon's bought them all.
There's
Yep.
if like we're based like Bradford, I know a couple of people from Farnells. They are part of, I think, 2 or 3 of the UK like backers for Pi. But what I've done for a corporate office in Manchester, they wanted to they lease the building, or they have the facilities management company. They outsource, or like the people who look after the building, like electricians, the heating systems, the lighting systems. They got like a silly quote, like a lot of like tens of thousands of pounds to IoT, the lighting system, like the heating system, the HVAC for summer, because climate change is, I think, like Maria is based in like Europe, like Greece. But we had like one guy here who said you can actually download the program onto a Pi, and then you put the Pi onto like an IoT VLAN, so it's not on your internal network. With Farnells, I know a couple of people there. They're over in the far side of Leeds now, but from their warehouse, if they don't do one Pi, you can always say, what Pi models do you have in? So if you can, they do like some refurb ones as well, like they've had returns. So if you just want to play with one, Pete Codes is quite good. Just tweet him a message and ask him. But I've often, we've put what we do for, because I mainly work as a contractor, so I'm on different projects. But what I found is if you keep like a list of the Pi device that you've got, make a note of the MAC address, make a note of how long you're going to support the project for, and then at the end of 6 or 12 months, when you pull the Pi back, you can then obviously wipe it, redeploy it, use it for something else. We've had a lot of people buying them, and then they forget where they put them, or they're up in the roof somewhere, or behind a smart TV, or like an IoT sensor. But like everything I followed is from Maria. There's a guy called Paul DiCarlo. He works for Microsoft in the US. I think Maria and Pete Codes both know him quite well. But Knott's IoT, everything I've learned from them, like the company in Manchester, they outsourced to some big like Interserve or something similar. For the facilities management, because they said, oh, the electric's too much and the heating's too much and it's too hot, too cold. I said, look, you can just download the code off like GitHub. I'm not a developer, but I look after devs in the office for my day job. So I got them to do the coding. I said, look, you get stuck, come get me, but don't stick it on the internal network, because obviously it's got like an external IP, or it needs like remote access. So what we did, we got the network guys, we got the buy-in from them. We said, look, this is what we want to do, save some money. Office wants to spend a lot, like boss doesn't want to spend a lot, but facilities management want a lot to go for something fancy. But Farnells is quite good, and I think it's CPC Farnells. They're the two that we've bought from. But like I said, keep a tally of where you use them, and then if you say, look, company is going to buy some, or you're going to get one for home, remember where you put it, because even the old Raspberry Pi, like the 2, the 3, and the 4, when you've done, get them back, refurb them, and then use them for something else.
Cool.
Also,
Thanks for that, Andrew. Yeah.
It's just what I've learned from like Maria, from Pete, from Paul DiCarlo. There's it's NVIDIA Jetson, I think it is, and he put on Twitter like some gizmo that reminded me more of a Bitcoin mining rig, which is why I thought of like Simon Lee, because like when he's going for a GPU, what are you doing with that? But I've walked down corridors, the CAD people at work. And what they've done, they've got the old GPUs, stuck them on a rig by the window. And I thought, how many GPUs and what are you doing with that? But then one of the guys is actually a pen tester. So he's using the GPUs for obviously password cracking or security cracking. But all of that links into the IoT that you can, there's a guy who does Northern Azure User Group. He used to be part of I forget the name. It's Kirk Ryan. Kirk Ryan built a Raspberry Pi cluster with AKS, but he used a Pi cluster, bought like 3 or 4 or 5 Pis, and Thomas Morrow did it as well. But they each did it a different way. So if you've got someone who wants to dabble with a Pi cluster, use like IoT, you can do it with a Pi. But yeah, I think we had to get. I think one of the guys broke one. I think Alan's saying 4, but I think one of the guys broke one, and we had to get a different case for the chassis. But Paul DiCarlo, you can pick different bits. But any company where you work, anyone you work with in like a corporate office, you've got facilities management. They're a good thing for IoT, and you can use that with the Pi. But
no, cool. Thank you, Andrew. Also, there's if you're UK based, I saw this the other day, came in my email. There's 3 pop locations where you can buy. They'll be selling all their kit. One's actually in Edinburgh, I think Newcastle and London. But I'll put a link in the chat for anybody who's interested.
And because Andrew mentioned Pete and Paul, I want to mention also Cliff and Jonny Tips that deal with IoT, and they are excellent IoT professionals and content creators.
yeah,
Cool.
the best thing is what I've found. If anyone's interested, like I'm just an IT guy. I mean, what do I know? I just work somewhere. But when I've looked after the last 2 years, like facilities management, their company's getting targeted now because they're outsourced. They have a contract with the company where I was working, for example, in Manchester, they had a KPI to save 30% electric like over the year. And how did they do that? The lighting system's not compatible. They have to rip it all out. But what we managed to do is the control unit for each floor, you can attach that for some to like an IoT gear. And then what Maria and Pete and all the others, I think Cliff is a pilot, so that's pretty cool. But each person shares like the libraries, so you can maybe ping them a message like Maria. I've shared their details to someone else, like one of the developers, and we had like the report. If you collect the information and your boss doesn't want to do it, say, look, why don't you try it for 3 months? What's a pie? 100, 150 quid max with all the extras, or 50 quid? Put it on an external LAN. And then if you negotiate a deal, get an IoT R&D budget. And then we had the software developers looking after facilities management. And then finally, I think just before I left last year, we got the HVAC system fixed because it's now IoT enabled. But the cool thing with that is you can scale that out. So all the other like offices around like Northeast, Northwest, they now have a couple £100 per office instead of like tens of thousands of pounds for some expensive system. But I left after that. But it's all like people like Maria, they tweet, I've done this. People like Cliff, I can't solder, but Pete Codes is always like, you can solder this, you can solve that. I can't do that. But if you find like an electrician or someone in facilities management, if they can solder, you've got your buddy there to get, because I don't want to lose my fingers. But yeah, it's just something I dabble with. But and then just make sure you do the IoT security, because you don't want to get hacked. Never forget that.
Absolutely, security is important. Cool, thank you very much. Has anyone else got any questions? Or thanks for that, Andrew. We're really some really good information there.
There's no other questions in the chat, Imran.
Okay. Should we move on to the next session?